Hello, everybody. A warm welcome from Berlin, as usual. Today, we are going to look into log anomaly detection in the freshly released IBM Cloud Pak for AIOps. And as guest speaker, we have Warren with us. Warren is a product manager for AIOps, and he's part of IBM Research and Development. You know me already. I'm Fred. So today's agenda, we are going to look into log anomaly detection golden signals. That's the whole topic. We are starting with data ingest, what to do, where to get the data from. Warren has a demo system set up. He's going to follow up with baselining and then going into anomaly detection itself. Then we are going to correlate the found anomalies with additional insights, in this case with metric data. And then we're going to follow up with the incident creation. And after the demo, I'm going to follow up with a link into the documentation. And with that, we are prepped for the great insights that Warren is going to deliver to us. So welcome, Warren. Over to you.
Welcome to the Cloud Pak for AIOps. We're starting today's walkthrough in the resource management view, which gives a visual topological representation of the components in this robot shop application and how they're all connected. So we can see all the layers from the fiber level to routers to particular messaging queues, databases, and this offers a very quick visual snapshot of which components may be good to focus in on. Red ones indicate the critical situations, yellow one indicate more minor warning signals. And across all different data types, this is a very good starting point. But let's say an IT operator or SRE wants to drill deep into errors from a particular data source, for example, logs. And they could do that if they define an integration and connector that feeds that data into the AIOps system. So in this environment, we have a Kafka integration defined, and there's just a few key parameters to configure. Specifically, the most pertinent one is field mapping, where any incoming JSON payloads must be mapped to the alert schema that AIOps recognizes. And there's details of how this could be done in the documentation. So once this mapping is defined and there's data coming into the system, algorithms can train from that data and understand baseline behavior. We can see this exhibited in log anomaly golden signals, which is one of the key capabilities launched in recent releases of AIOps. And the power of this algorithm is that it takes all that messy raw log data, it understands typical message patterns, creates templates out of them, categorizes those templates against industry standard golden signals. And by delineating information in this way, higher volumes of data can be more effectively processed, the explainability is improved, and there's lower footprint requirements for this capability as well. So let's see examples of what some of these templates look like. You can see the system was able to create 789 templates from the data, but it's also intelligent enough to identify the 58 most pertinent ones out of those 789. And if we click into one of these examples, for example, the one with ID 202, we can see some of the metadata associated with it. We can see there's indicators of instana, something about a 404 code. And so that gives a very good starting point for the end user to have a better sense of what may be the issue. And if the template name is too messy, the user can easily rename it to something more manageable. So when subsequent anomalies are identified against this specific pattern, they know at a glance what they need to do next. Now let's see how this could be represented in the actual alert itself that comes in when there's a problem. Let's go to the alert view in AIOps, and we could do a quick search for log. Now, this is a powerful representation of how it's not just log data coming into this view, it's network data across different connectors. It is different types of log connectors, right? So other ELK connections. But we see the log template 202 we were taking a look at here represented within the alert view as well. You can see the metadata associated with it. And you can also see a visual representation of the data. So you can see the root cause at particular timestamps, right? What time do you need to look further into? So this is the overall timeline, and we can actually focus on a particular time. So see an anomaly occurred sometime between 4:30 and 5 p.m. Working with a baseline of 0, it's spiked dramatically to 22. and then 14, but still much higher than normal. We can cross-correlate with other types of metrics to showcase how this is an indicator of a problem. You can see there's a direct correlation of transactions per second and this 404 error, which intuitively makes sense. If there's an outage, if a page is unavailable, then the transactions per second are going to drop dramatically. And this is just one of the types of correlations that is available through the metrics that users could select. You can see the list available here. And again, just exemplifies the power of having lots of different data sources piped into one single system for analysis. Let's go back to the alert view for a moment. We can pull up log one real quickly. We can also see the topological representation of this log template, right? And we can see that it's a user service that would be good to look into. We can see that the components that it's connected to that may have downstream effects to the particular Kubernetes service cluster, to the payment service, to various databases. Again, just giving that very succinct point of view on the key components that the IT operator could look into first. And this could be augmented even further with the leveraging of incidents, which upon the creation of a policy groups the alerts together into something that is a much more powerful synthesis of relevant third-party sources of data, runbooks that could resolve the situation, past resolution tickets that may contain pertinent information for how to resolve the situation at hand, other cascading, impacting implications. So with log anomaly and metric anomaly, there's the power to see those discrepancies of what happened, right? And there's a power of connecting that to the broader environment and what's going on. So I hope this gave you a helpful overview of the potential and power of log anomaly golden signals in an enterprise IT environment. Happy to answer any questions at this time.
Thank you, Warren. That was great. I loved it already. So log anomaly detection is something we do not see in every single AIOps installation. So therefore, looking forward to have more customers looking into this topic. And I hope this video is going to support this kind of installation piece. So where to start with log anomaly detection? So as we have our current release 4.10.0, here is a link. So when you search for log anomaly, then you will see a number of links. And in the chapter about AI algorithms, you will find this piece. This is a good starting point. And from here, you can start reading into the topic. So that's it for today. Without further ado, we are done. And before I let you go, I have to thank you. Thank you for spending some time with us again. Thank you to Warren, a special warm thank you to Warren for preparing all the material and demoing it to us. And thank you from my side for spending some time with us on this AIOps Explained instance. And see you another time when it's again AIOps Explained. See you. Bye.